Okay, tonight we are going to try all, maybe all of them, but many of the questions from the College Board question bank. I will have already done many of these questions as they are simply reproductions of what is in the um, Blue Book application. So if you watched any of those videos of my run-throughs of those tests, then many of these questions will have shown up there. The difference being here is that we're going to break it down by topic. Tonight I am working through the what they call linear functions, not to be confused with linear expressions or linear equations in one variable or two variables. Those are different things. They're calling these linear functions, and my purpose in doing these is to familiarize myself with the nature of these questions so that I can coach my students better, but also so that there's in existence a walkthrough for the entire question bank. My goal is over the next several weeks to go through every single question that the College Board has produced and make it available for you guys. So hopefully you can learn something from going through this with me. The first thing that I'm going to do is before we even get started, we're going to define some things. We're going to make sure that we know our basic principles or basic definitions as we go through this. So the first thing that we want is, what is a linear function? A linear function, well, let's start with, what is a function? A function is basically an expression, a mathematical expression, and literally an expression. Math is language. A mathematical phrase that tells us what to do with a certain input, and it provides a specific output. So we would say something like f of x, the function f acting on x, is equal to, in the form that you might be familiar with, is mx plus b, where m is the slope. Some people might refer to this as the rate of change, and b is our y-intercept, also understood to be the beginning value, especially if we're doing a practical application or like a real life scenario. So slope is also the rate, and the y-intercept is the beginning value. So with those definitions, let's dive right in. That's really all we're going to need, I think. So let's take a look. We've got total cost f of x, and if you're not familiar with a function notation like that, just study it. It's just a fancy way of saying y. Function f acting on x is for 36 months from a particular dealership is given by this function. Again, we have a slope, 36. Not letting me highlight it, but it is 36 plus 1,000. We should understand this to mean that there's a $1,000 beginning value, and 36 is the number of months. So x must be like the cost per month. Yeah, exactly what it says. X is the monthly payment. What is the total cost to lease a car when the monthly payment is $400? So we're going to plug that in for x, because that's exactly what it says. You could plug this into Desmos, but I'm going to show how to do this by hand tonight. So f of x is our function, but basically 400 is going to replace the x because x is the monthly payment. And they tell us the monthly payment is 400. 36 times 400 plus 1,000. 36 times 400. 36 times 4 is 120 plus 24, 144 plus 2 zeros, so 14,400 plus 1,000 is 15,500. So the answer to, I'm just going to use the last 3 digits there, C8C, is, the answer is C. I'll be checking my work after I do a few here. We'll call that number 1. Let's see. Excuse me. All right. Can't have just one sneeze. All right. Question number 2. Linear functions again, obviously, because that's the PDF that I have here. And if you're wondering how I got this PDF, I just went through the Collegeboard website. You can search question bank and filter by type of question and download as many as you like to do. I just downloaded all of them by category. Took a long time to do, but in the end, I hope it'll be worth it for my own edification and hopefully career building. So all of our answer choices are linear functions this time. This question 2, ending code 702. We got 220 for the first 2 hours. Total cost of 5 hours is 400. So we should understand those to be XY coordinate points. So it was 2 hours for 220. So we should understand this to be like hours, comma, cost as our X and Y coordinate points. The other one was 400. And because we're dealing with linear functions, we know that the slope is equal to change in Y divided by change in X. So change in Y is 180. Change in X is 3. So the slope is 60. And again, that's 400 minus 220 is 180. And 5 minus 2 is 3. And of course, 180 divided by 3 is 60. So that's going to be our slope. And we might be tempted to pick 220 as the y-intercept, but that's not the y-intercept. It was 220 for the first 2 hours. So it can't possibly be the y-intercept. So I already know that the answer is A. But for you guys, how did I get there? I'm thinking logically about the answer choices. I know that the slope is 60, so it can't possibly be C or D. Looking at the answer choices A and B, we know that the coordinate point 2, 220 exists on this line. So the y-intercept must be less than 220 because the slope is positive. This thing's going to go like that. And if this is 2, 220 right there, then 0, something must be less than 220. And that's just thinking about it logically. If we wanted to solve this algebraically, we certainly could. I'll do it over here. We could do, okay, our slope is 60. We have a coordinate point. So I could say 400 equals 60 times 5 plus b, and solve for the y-intercept that way. 60 times 5 is 300 plus b. Subtract the 300 over, and you get 100 equals b. That's one way to do it algebraically. The other way to do it is to use point-slope form. So they tell us that it goes through 2, 220, so we could say y minus 220 equals 60, our slope, times x minus 2. We distribute those through. We get y minus 220 equals 60x minus 120, distributing the 60 to each term. Combining like terms here, adding the 220 over, we get y equals 60x plus 100 again. So either way you slice it, we know that that's true. And again, you could push this into Desmos if you like, but I want to show you guys that these things can be done algebraically without too much trouble. This is question 929. And again, I'm just using those last digits there to keep track of which one I'm doing. What have the difficulties been so far? That's ranked as hard, sure. This is ranked as easy. Yeah. This one's medium. All right. So we have a linear function h. Remember, h is just the name of the function. Another way to say y, which is basically what this phrase here means. Y equals h of x. 4x plus 28. 4 is our slope. 28 is our y-intercept. Has an x-intercept at a0 and a y-intercept at 0b. We already know that the y-intercept is 28, so we know b is 28. And they're asking for the value of a plus b. This phrase right here, a and b are constants. Don't get hung up on the phrase constant. Constant just means that it's a specific number. Too often, students that I work with get hung up and confused by that. It just means that it's a particular number. Whatever that number is, we don't often care. So it's not mathematically important to dwell on it being a constant. So what we're going to do here is we're going to just plug in, we know b is 28 by the definition of a y-intercept. Because whenever x is 0, you've got the y-intercept, and the y-intercept is that value 28 right there. To get the a value, we plug in y is 0, so 0 equals 4x plus 28. Subtract the 28 over, divide by the 4, and we get x is equal to -7. So really we should be writing a here, because that was the coordinate point, a comma 0. So a is -7, and they want the sum of a and b, so -7 plus 28, of course, is 21. So that makes the answer A. Moving on to the next one. Another hard question. This is question 4 for us today. Code 65F. The reason I'm writing those down is because I'm going to cross-reference this against the answer key, which I have open in another PDF here. So that's why that's there. All right. Oh, word problem this time. I'll zoom in on that, because I think it might be too small for some of you guys. All right. We don't often care about the context on these. What we care about is identifying that linear function again. They might give us a slope or rate of change. They might give us coordinate points where we find the slope, find the y-intercept, that kind of thing. Linear function, selling price P. Demand was 20,000 units when the price was 40. 50,000 units when it was 60. So that we should understand to be an XY coordinate pair. So we've got 40, 20,000 as one XY coordinate, and then we have 60, 15,000. So by evaluating that, we should see that X goes up, Y goes down. We know that our slope is going to be negative. Change in Y is negative 5,000. Change in X is 20. Cross the zeros off. 500 divided by 2 is 250. So negative 250 becomes our slope, X plus B. So y equals negative 250x plus b. We could plug in a coordinate point and find the y-intercept. They want to know when 55 is x, what's the result? So I'm going to go ahead and do that. There's another way to do this that comes to my mind. We could set up a system of equations with point-slope form. That may be more work. It would be really easy in Desmos. But we're not doing Desmos tonight. We're doing the hard way. Okay, so 250x plus b, plug in the 40 into 20,000, so 20,000 equals negative 250 times 40 plus b. 25 times 4 is 100. Put 2 zeros on the end, you get 10,000. So negative 10,000 plus b equals 20,000. Add the 10,000 over and we get 30,000 for our y-intercept. Bring that back to our original function, negative 250 x, but x this time we're going to use 55 plus 30,000. All right, 25 times 55. Ooh, a big number. Probably use a calculator for that in most circumstances. 25 times 5 is 125. So 10,000, 1,000, what's that going to be? 12,500 plus 1,250. That's negative, so whatever. That's 13,750 negative plus 30,000. So it's going to end in a 250. So it's probably A. I'm going to double check my math with a calculator here. 250 times 55. Yep. Ooh, I'm impressing myself. I did that correctly. 16,250. All right, I'm going to go ahead and commit to that. Answer is yet again A. Don't be intimidated by patterns. Sometimes patterns emerge out of randomness. It's just the way the world is sometimes. This one doesn't fit on the screen there, so I'll zoom out. This is question 5, code ending 6A2. And we're at 15 minutes, so this will be the last one, and then I'll stop the video here to make it so that it's not incredibly long. But hopefully this is demonstrating some of the skills. I'm going to go through more of the linear functions in another video and post it after this one. But I want to keep these things to less than 20 minutes so it's not overwhelming. So let's go through this one. We got, again, all of our answer choices are linear functions. We got 10 days is 270. First day is 1. Okay, this is very similar to that other one where they're giving us an XY coordinate point there. The 10 days is not terribly helpful, but 270 and the first day. So we should understand that to be 1, 270 as a coordinate pair. And 135 for each additional day. So that's our slope, m equals 135. How do I erase? Get my eraser. There we go. 135. Which of the following gives the cost? So we know the slope is 135, so it's either C or D. It's tempting to choose C, but remember the thing that we talked about earlier is that if the coordinate point 1, 270 is already on the line out here, 1, 270, then this point right here is 0, something. Can't possibly also be 270 if the slope isn't 0. So it must be D. But we can go ahead and go through the math on this, but we've already solved it thinking logically. So again, point slope seems to be the way to go. We seem to be using that fairly frequently in the first 5 here, 2 out of the 5. So point slope again is y minus the y coordinate, 270, equal the slope times x minus the x coordinate. Distribute and combine like terms. Y equals 135x minus 135. Add the 270 over. 135x. And 135 is indeed half of that, so 270 minus 135 is just 135 again. And so therefore we do confirm our answer D. Let's go ahead and check our work at this point. Okay, we got C, A, D, C, triple A, D. So we got C, A, and D. Excellent. If you learned something, leave a comment in the comment section below. If you think that there are better ways to do this, let me know. If you found any shortcuts that I may have missed, again, several of these things could have been solved very quickly with Desmos, just plugging it in, but my goal today was to show the algebraic approach. Many of these things do have just graphing shortcuts. And if you have any tips on that, again, share your favorite tips in the comment section below. If you liked our demonstration on this today, please give me a thumbs up and a subscribe. I will hopefully be able to commit the time to doing the entirety of the question bank, which includes hundreds and hundreds and hundreds of questions. So I do expect this to take me some time to do. And if you want to come along that journey with me, just hit that subscribe button and you will know what to do. Thanks for watching.